Today's notes are over an introduction to trigonometry. And the first thing we're going to talk about are angles in standard position. What is standard position? An angle is in standard position when its vertex is at the origin. One ray, which a ray, if you recall, has a fixed point on one side and my line shoots out in one direction. Okay, that's a ray. One ray, known as the initial side, is on the x-axis, and the other ray, known as the terminal side, is rotated about the vertex. And if the vertex is at the origin, that terminal side is rotated about the origin. So I have an example for you here. I have an angle shown in standard position on the coordinate plane, which means I have my axes drawn. I have my x-axis here, my y-axis here, I have my vertex at the origin. And then as you can see, that one ray that is in blue shoots out along the x-axis. That's known as the initial side. And then the terminal side is rotated about that vertex. And as you can see, the terminal side is shown in pink here, and that's how we would show that angle measure. So for whatever reason, when I just show you an angle, or when I show students an angle that looks like this, and I say, okay, this angle measure is 120, or let's say 140 degrees. Students are really good with this. Okay, that angle measure is 140 degrees. When I put things on the coordinate plane, it tends to confuse students a little bit, but it's really the same thing. I've basically taken this angle, I've put it on the coordinate plane. The only thing you can see here are my x and y axes, but let's say that the same angle measure is 140 degrees. So what I want to talk about is how we measure these angles on the coordinate plane. As you can see, when I rotate to the left this way, that's counterclockwise. When you think about a clock, right? That's the opposite of how we measure a clock. Those are positive angles. So positive angles are rotated counterclockwise. Negative angles are rotated clockwise. If I had an angle that went all the way around, that looks like a circle. How many degrees are in a circle? 360 degrees. So now let's talk about these angle measures on this coordinate plane. If I had my initial side and my terminal side shooting out along the x-axis, that would be a 0-degree angle. If I had my initial side on the x-axis, my terminal side on the y-axis, that right there would be 90 degrees. If I had my initial side on the x-axis, my terminal side on the x-axis shooting out to the left, that would be 180 degrees. If I went all the way around to this line right here, that would be an extra 90 degrees. That's 270 degrees. And if I went all the way around back to that x-axis on the right side, that initial side, that's 360 degrees. So that's how we're going to show measure on using angles in standard position on the coordinate plane. Okay, now let's move on to the next little section. And it says to draw each angle in standard position. So let's try this out. Number 1 says 200 degrees. So what is that going to look like? I know that along my x-axis, this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270 degrees. I know that my initial side, my vertex is at the origin, my initial side is on the x-axis, shooting out to the right, and then I'm going to rotate it 200 degrees counterclockwise. Well, it's not going to go, if I go all the way to 180, or like to the other side in the opposite direction, that's 180. So I need 20 more degrees, which will be about right there. There's going to be my terminal side for this particular angle. So let me draw this a little better. This is this angle in standard position. And I'll change colors here to show you. Right here, that's my 200-degree angle. Now number 2 says 495 degrees. Okay, what is that going to look like? Well, I know all the way around is 360 degrees. Well, 495 degrees, how many more degree measures do I need to go to get to 495 degrees? Well, an initial 90 degrees, which would get me right here, would be 450 degrees. I need 45 more degrees to get to 495, which is, let's do that. First, let's show our angle measures, right? So this is 0 degrees. Up here's 90 degrees if I'm rotating counterclockwise. Over here's 180. Down here's 270. Back all the way around, we're back to 360. If I added another 90 degrees, if I kept going, right, I'm just going, I'm going. If I added another 90 degrees, oh my gosh, I meant to erase that, sorry. If I added another 90 degrees, I'm at 450. And I can keep going, right? I can keep just adding 90 degrees, 90 degrees, 90 degrees. And then another 45 degrees, which if you recall, if this angle is 90 degrees right here, 45 degrees splits that angle in half, right? It bisects that angle. So this right here would be the terminal side for this angle. So what does this look like? How does that even, how could we even show this? So my initial side is on the x-axis. To get to 495 degrees, what I have to do is go all the way around to 360, adding another 90 to get to 450, adding another 45 to get to 495. And that's my 495 degree angle. So I can keep going. That's how I show this angle in standard position. Now let's look at number 3. Here's a negative angle. It's negative 80 degrees. Well, if you recall, my vertex is at the origin. My initial side is still on the x-axis shooting out towards the right. Angles in standard position, the positive angles are rotated counterclockwise, negative angles are rotated clockwise. So instead of moving to the left, I'm going to move to the right or clockwise. Okay, so this right here is a 90-degree angle, this x-axis and this y-axis down here. So 80 degrees is going to be about right there. Right, so now what we're looking at is this angle measure right here is negative 80 degrees. That's how we show that negative angle. Sorry, I meant to erase this. That negative angle in standard position on the coordinate plane. So now let's talk about coterminal angles. This is a new vocabulary word. Coterminal angles, what are they? They end in the same position and have the same terminal side. In example 3, so that's this example right here. Let me change. In example 3, 280 degrees and negative 80 degrees are coterminal angles. They can be found by adding or subtracting 360 degrees. And I'm going to write or a multiple of 360. Or a multiple of 360. So I'm just going to show you on here. If I have negative 80 degrees, if I were to add 280 degrees, or I'm sorry, not add 280 degrees, but if I were to go 280 degrees counterclockwise, so the positive degree measure, that ends in the same position. So let's say I were to show the angle 280 degrees in standard position on the coordinate plane. I would start with my initial side on the x-axis, and I would rotate the terminal side counterclockwise, and it would end right here. That's the same terminal side of the angle negative 80 degrees, which means 280 degrees and negative 80 degrees are coterminal angles. They end in the same position. So number 4 says find one positive angle and one negative angle that are coterminal with the angle that measures negative 15 degrees. Well, I can add 360 or subtract 360 to get a coterminal angle. So if I take negative 15 and I subtract 360, that'll give me an angle that's negative. And I get negative 375 degrees. So if I were to show the angle negative 375 degrees in standard position on the coordinate plane, and the angle negative 15 degrees in standard position on the coordinate plane, they would look the same. They end in the same position, okay? They are coterminal. Well, let's look at, if I take negative 15 and I add 360. Now I've got 360 and negative 15, I get positive 345 degrees. If I were to graph or show 345 degrees in standard position on the coordinate plane, it would end in the same position as negative 375 degrees and negative 15 degrees. They all end in the same position on the coordinate plane. All right, let's move on to reference angles. What are reference angles? So we've talked about coterminal angles. We've talked about angles in standard position. Now let's look at reference angles. A reference angle. Oh, that's not what I wanted to do. I wanted to highlight that. A reference angle is the angle between the terminal side of an angle in standard position and the x-axis. So it's always less than 90 degrees. That's what you really need to remember. So let's say I'm going to draw the angle 140 degrees. And that's going to look about like this, right? So there's my terminal side. Here's my initial side. Sorry, that's kind of a little much there, but there's my initial side, and this angle measure is 140 degrees. So what's the reference angle? Where the reference angle is it's between the terminal side and the x-axis, and it's always less than 90 degrees. So that means this right here, this angle measure between that terminal side and the x-axis is your reference angle. So 140 degrees, well, I need how many more to get to? I know this is 180 degrees. I need 40 more. This reference angle right here is 40 degrees. That right there, and I'm going to draw it in a different color. This angle measure is your reference angle. That is your reference angle, and it's always less than 90 degrees. So, you know, let's do some examples. Numbers 5 through 7. Number 5 says 135 degrees. If I were to draw 135 in standard position, I've got my initial side on the x-axis. Sorry, I'm not drawing these very well. I wish this would draw a straight line. 135 degrees is right here, okay? This right here is a 135 degree angle. The terminal side is in quadrant 2. My reference angle is between this terminal side and the x-axis, right? Right there, that is my reference angle. So right here, let's say that's my reference angle. What's the degree measure? Well, 135, how much more do I need to get to 180 degrees? Well, I could always do 180 minus 135, and I get 45 degrees. So this reference angle is 45 degrees. Let's move on to number 6. Number 6, 380 degrees. So I know that my vertex is going to be at the origin in standard position. Initial side moves out to the right along the x-axis. If I go all the way around, I'm at 360 degrees, so an extra 20 degrees is going to be where my terminal side lies. So that's in quadrant 1. So this angle measure is 380 degrees, which means my reference angle is between that terminal side and the x-axis, which means this is my reference angle. What degree is that? Well, 380 degrees, I need to get back to this x-axis, which all the way around was 360 degrees. So I can do 380 minus 360, and I get 20. This is 20 degrees, and that is my reference angle. Let's move on to number 7. Number 7 says negative 100 degrees. Well, in this case, I've got my vertex at the origin. Initial side goes along the x-axis to the right, and now I'm moving clockwise to show negative 100 degrees in standard position. I know if I go all the way down to this y-axis down here that splits those the third and fourth quadrant, that's 90 degrees, which means, or negative 90 degrees, and I need to go 10 degrees more, which means my terminal side would lie right here. okay? Right there shows a degree or an angle at negative 100 degrees in standard position on the coordinate plane. So right here. So now what's my reference angle? Well, my reference angle, because it's less than 90 degrees, my reference angle is going to be this terminal side all the way to the x-axis right here. That reference angle, how many more do I need to go to get to that x-axis? Well, this right here, this is 10 degrees. I know this entire right angle measures 90 degrees. So all the way around, I need 80 more. This angle measure is 80 degrees. And that right there is our reference angle. So how many more do I need to get to? Or, what's the difference, right? This right here is going to be 10 degrees. I need 80 more to get to 90 degrees. You can also look at the fact that, this entire degree right here is 180, right? And this is 100. I'm just using positive angle measures. And this is 100. So you could do 180 minus 100 and you would get 80 degrees. You can also look at it that way. I like to look at it as how many more do I need to get to 180, right? That would be my degree measure that I would need for my reference angle. So let's move on and talk about radians. This is just an introduction to trigonometry. So we've shown angles in standard position, coterminal angles, reference angles. This is all new vocabulary. And now we're going to talk about radians. What is a radian? A radian is a unit of measure based on arc length. 1 radian is the measure of an angle in standard position, which we talked about, whose terminal side intercepts an arc of length r. So here's what that means. What do I have? What am I looking at on this image right here? I have a circle put on the coordinate plane with the center of this circle at the origin, right here. Let's say I have a radius of this circle, which would go from the center all the way to this point on my circle. That has a length r. And let's say I have right here, I have the terminal side of an angle lying right here, and we'll call this also length r. How could I give them the same length? Well, their radii, right? So I know that the distance from this center point to any point on this circle is the same distance. So I have 2 radiuses here, right? 2 radii that have a length of r. 1 radian is the length of this arc. That is 1 radian. So that's the same length. 1 radian is the length of that arc when I have I have an angle, right, that have 2 of the same radiuses, right? Of the same radiuses, that doesn't make any sense. But I have 2, here's 1 radius, here's another radius, here's my angle. This arc right here the measure is 1 radian. Okay, so now let's talk about a radius. If with a radius of a circle as 1 radian, the circumference is, well, I know the circumference of a circle is 2 pi r, okay? If the radius of the circle is 1 radian, meaning this right here is 1 radian, then I know the circumference is going to be 2 times pi times 1, right? I'm just evaluating when r is 1, right? What's the circumference when r is 1? In this case, I know that the circumference of a circle is 2 pi, because 2 pi times 1 is just 2 pi, and that's 2 pi radians. So this is just a way that we can show measure on the coordinate plane. All right, we're going to talk about degree measures. In this case, we're talking about radian measures, and it's based on arc length. Okay, so how many of these r's go all the way around this circle? 2 pi. which pi is just 3.14. So that's like 2 times 3.14. Blah, 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 right? It's an irrational number. It never ends and it never repeats. So let's move on to converting between degrees and radians. And remember, this is just an introduction to trigonometry. So all of these little skills that I'm showing you, little concepts, we'll be using in the next several lessons over our trigonometry unit for Algebra 2. Okay, this is our last page of notes. Converting between degrees and radians. So one of the things that we need to know is that 2 pi radians, so all the way around this circle is 2 pi, right? The circumference in radians is 2 pi. That equals 360 degrees because I know from previous, middle school math and, geometry, which you would have taken by this point, goes all the way around 360 degrees. So in radians, all the way around is 2 pi, and in degree measures, all the way around is 360 degrees, which means pi radians, or half of that, would be 180 degrees. So let's look at this. When I talk about degree measures and radians, let's first talk about, how we look at this particular circle in radian measure. Well, I know if this is my vertex and this is my initial side, right? When I'm talking about angle measures, I know I'm at 0, right? All the way around in radians would be 2 pi, which means halfway around would be pi, right? Half of 2, which means a quarter of the way around would be half of pi. 1/2 pi is the same thing as pi over 2. So I'm going to write this as pi over 2. And what I'm going to do now is I'm going to kind of talk about this like in a different way. I know that each 90-degree angle, which we've kind of looked at here, is going to be pi over 2. So I'm going to count in terms of that, right? If this is pi over 2 and I go all the way to here, that's really 2 pi over 2, which 2 pi over 2 is just pi. If I go all the way to here, I've added another pi over 2. I'm now at 3 pi over 2. And then if I go all the way over here, I'm at 4 pi over 2, which just simplifies to 2 pi, right? That's how it simplifies to 2 pi. And that's how we get these radian measures on this circle that's put on this coordinate plane, okay? So now let's look at how we might get, what if I were to bisect this angle measure right here? I'm bisecting pi over 2. I'm going to split it in half. Well, let's think about that. If I take 1/2 of pi over 2, I'm at pi over 4, right? 1/2 of something, I multiply. Half of pi over 2, I'm at pi over 4. Okay, well then now let's count by fourths. Pi over 4 would be here. All the way up to this point right here is 2 pi over 4. Putting this over here, 2 pi over 4 is the same thing as pi over 2. Pi over 2. Well, let's say I split this one in half. What am I at right there? I'm at 3 pi over 4. Here I'm at 4 pi over 4, which 4 pi over 4 is just pi. So we're getting the same thing. All right, let's split this angle in half, and we're counting by fourths here. 4 pi over 4. This is 5 pi over 4. This is 6 pi over 4. What would this be? 7 pi over 4. And we'll get into this more like in tomorrow's lesson, but this is like how I'm kind of breaking up the measures on this circle, which we're so used to showing this in degrees. Remember, in degrees, I have 0 degrees over here. I go up, I have 90 degrees. Here's 180 degrees, add another 90 degrees to get 270 degrees, add another 90 degrees to get 360 degrees. This is another way we show measure. So now let's look at, can you determine a reference angle in radian measure? Yes, you can. The first thing you're going to do is you're going to determine the quadrant, right? Are we in quadrant 1, 2, 3, or 4? And then this, how I like to think about it, is how much more or less to pi or 2 pi. So, and you can always subtract. How much more or less do you need to get to pi or 2 pi? Which, if we look at all the way around is 2 pi, halfway around is pi. So what I really like to do, a little helpful hint when we talk about reference angles in radians, is to sketch it. Sketch it. And so I'm just going to show you really quickly. Let's say I have, let's say if I have 3 pi over 5. Okay, 3 pi over 5. That would be in quadrant 2, because let's say I've got my coordinate plane right here, and I'm counting by 3 pi over 5 means I've got this whole right here, this straight line measures in pi. If I'm counting by 3 pi over 5, I'm counting by fifths, right? So 1 pi over 5 would be in our first quadrant. 2 pi over 5 still in our first quadrant. 3 pi over 5 would be in this quadrant too right here, right? This would be 3 pi over 5. I know that 3/5 is more than 1/2. I know that's a bigger fraction than 1/2. Right up here, my 90-degree angle right here is the same thing as pi over 2, or that's like half. So 3 pi over 5 is going to be more than that. It's going to be in quadrant 2. So how many more do I need to get to pi? Well, right here would be 4 pi over 5. That would be 5 pi over 5, which means what do I need? I need 2 pi over 5. So 3 pi over 5 is in quadrant 2. And there's not a lot of this in today's assignment. I need 2 pi over 5 to make 5 pi over 5, which equals pi. Okay, so to get to that pi over here, this is 0, that's pi. I need 2 pi over 5 to get to that pi. So really, when we're talking about radians, you need to be pretty good with fractions. And the last little bit in today's lesson, we're going to be converting degrees to radians and radians to degrees. So in your today's assignment, you're going to be referencing your notes a lot. Okay, what do I need to do this part? What do I need to do and just reference your notes. So when I'm converting degrees to radians, I'm going to take the degree measure and I'm going to multiply it by pi over 180. So if I'm going to convert 145 to radians, I'm going to do 145 times pi over 180. Whoops, pi over 180. And when I take a whole number and multiply it by a fraction, I'm going to put that whole number over 1. 145 times pi over 180. What I like to do when I am multiplying fractions, which is what we're doing, is pre-simplify. Okay, so I know a common factor between 145 and 180 is 5. So let's divide by 5. And we're simplifying. 145 divided by 5 is 29. 180 divided by 5 is 36. Now when I multiply across, I get 29 pi over 36. And that is 145 degrees in radian measure, 29 pi over 36. Now let's move on to converting negative pi over 8 to degrees. Well, in this case, when I convert radians to degrees, I'm going to multiply the radian measure. This is a Greek symbol, theta, That just represents the angle in radian measure in this case. So the radian measure times 180 over pi. So I'm going to take negative pi over 8, and I'm going to multiply it by 180 over pi. So let's see what happens here. So in this case, I know the pi's are going to cancel out. That's how we get rid of the pi's. And now I need to simplify, or I like to pre-simplify, the 8 down here in my denominator and the 180 up here in my numerator. The greatest common factor between those numbers is 4. So I'm going to divide everything, or those, by 4. 8 divided by 4 is 2. 180 divided by 4 is 45. And now when I multiply across, a negative times a positive is a negative. And then I get 45 over 2. So negative 45 over 2 degrees, or I can do negative 45 divided by 2 is negative 22.5 degrees. And that concludes your notes over an introduction to trigonometry. I know these were long, but hopefully you with the video, you can pause the video, you can go back. If there was anything that was kind of confusing today, hopefully we'll clarify in the next lessons, especially how you show degrees on your coordinate plane when you've got a circle on it. So anyways, I hope these were helpful.